In my current episode, we will create this program from scratch. We will be using OpenGL Superbible OpenGL Programming Guide. Once we learn some basics about OpenGL, we can create complete library, our own OpenGL library, and can implement computer simulation. Looks like this. By using more advanced programming framework such as MFC and the .NET framework, we can create complete software applications. Please understand that I assume you are reading OpenGL Superbible 7th edition, also OpenGL Programming Guide 9th edition, while watching my videos. I will post source code in the membership window, so by the time you watch my current video, you will have another posting here, including the download link for the source code of my current video. Without further ado, let's get started. Open up Visual Studio. Go to File, New, Project. Select OpenGL Superbible 7. Click Next. From your working folder, select Folder. Solution name will be 101 OpenGL from scratch. Accept the default project name. Click Create. Press Ctrl F5. You should have this stub code. Now close it. Close it. From Solution Explorer, source files, source.cpp. I assume you have watched these videos. If you do not understand, restart primitive, triangle strip, vertex indices. It might be hard for you to follow my current session. Shader files. Right-click, add new item. Select utility text file. Say cube.but. We added one shader file. Right-click, add new item. Text file, cube, frag. Click Add. I will arrange side by side. This is Vertex shader. Vertex shader. Version 450 core. Copy. Paste it here. This is fragment shader. In the Vertex shader, we use uniform mat4 model matrix. Uniform mat4 projection matrix. In back4 position, in back4 color, out back4 vs color. Copy this, paste it here. It should be in, out back4 color, void main color vs color. fragment shader is very simple. Now save all. In the Vertex shader void main mat4 transform, we multiply two matrix times the model matrix GL position. We use transform matrix times the this input vertex. I would say transform matrix. Copy, paste it here. VS color. So this is output color for fragment shader VS color input. If you have been watching my previous videos, you should have no problem understanding these things. We will further test matrix. We get model matrix and the projection matrix from our C++ code. We multiply projection matrix with the model matrix. Then using this matrix, we transform our position, vertex position, then set GL position. Save all. We can close this. I will arrange side by side. I will auto hide. In this section, private GL name T program. Startup. This program we use create program by passing cube vertex shader fragment shader GL use program. This program. Now we check GL operation. Failed to build shaders. In future, I will not explain resource cleanup. At the shutdown function, of course, we need GL is program. This program equals GL true. GL delete program. This program. I will not make code for resource cleanup. I assume the audience to clean up OpenGL resources. Now press Ctrl F5. It should build and run successfully. Now close it. In the Vertex shader, we have two uniforms for transformation matrices. Also, we have two input attributes. These are attributes. These are uniforms. We need to retrieve indices like this. In the private section, GL int, I will copy, paste, model matrix index -1 GL int, projection matrix index -1 GL int, position index -1. gl int color index -1. We will retrieve these indices like this. This model matrix index gl get uniform location. This program we provide this name as a string. Throw if true. If this is equal to -1, failed to retrieve model matrix index. Copy, paste. Now projection matrix index. Here, also here. This is now projection matrix. Copy, paste. Now this is position index. We use gl get attrib location. This program we pass position here. Then position index -1. We failed to retrieve position index. Copy, paste. Now color index. Here we pass string color. Color index. If -1, then we failed to retrieve color index. Press Ctrl F5. It should build and run successfully. Now close it. Now scroll up. In this link, episode 92, OpenGL Rotating Cube 2. Please control click this link. From this video, episode 92, I explained how to create vertex indices. Show more. If you scroll down, you can find download source code link, episode 92. Right click, save link as. Click save. Keep. Show in folder, unzip it. In this folder, you can find restart primitive. Restart primitive. You can open programming guide app.cpp. If you scroll down, you can find these data up to this point. Copy, paste it here. So we got vertex position, vertex color, and vertex indices. Here I used restart primitives. Restart primitive. So I would highly recommend you to watch these two videos. Now Control End. I will fold it up. Here GL create vertex arrays. We create one, this VAO. Of course, we need address. Scroll up. Here, GL name T VAO initialize to 0 vertex array object. GL name T VBO set to 0 vertex buffer object. GL name t element buffer object. We will introduce one more type of buffer object. Instead of EBO element buffer object, I will use the full name element buffer object. So in this program, we are using two buffer objects. One is Vertex buffer object, another is element buffer object. We will initialize to 0. Now scroll down. Sorry, I made a mistake. Cut. In the startup function, we are in startup function. Here we create vertex array object, VAO for vertex array object. Don't forget GL bind vertex array. This VAO. Never forget bind the vertex array. This is super important. Now we create GL create buffers. We create this vertex buffer object, VBO for vertex buffer object. We have to bind buffer to its target, GL array buffer, this vertex buffer object. Never forget to bind the buffer to its target. The target in this case is GL array buffer or vertex buffer. Now we allocate memory GL buffer data, GL array buffer. So we are allocating memory for vertex array object because we use the same target. This is size of vertex positions plus this is for vertex attribute. This array, vertex array, we also need memory for vertex color. So we allocate size of vertex color 2 in a single GL array buffer. Then data. We have to initialize two memory blocks. One is for vertex position, another is for vertex color. We pass null for the time being. Usage, we will use GL static draw. Okay, we allocated the memory but haven't yet initialized. We allocated Vertex Buffer object whose target is glArrayVertexBuffer, but not yet initialized the buffer memory because we passed null. Now glBufferSubData glArrayVertexBuffer offset is 0 because we are going to initialize size of vertex positions. We initialize vertex positions. We initialized vertex buffer with vertex positions. So vertex positions are initialized for vertex buffer object. Now glBufferSubData glArrayVertexBuffer offset. Now we initialized vertex position already, so this is offset. We provide size of, we will initialize vertex color, then data vertex colors. We initialized vertex buffer, I say object, vertex buffer object with vertex colors. In case of vertex positions, we provide offset 0. In case of vertex colors, we provide the size of vertex position as offset. Then we initialize with vertex colors. Please compare this line with this line. Now we create element buffer object. Please understand that we are using two buffer objects, vertex buffer object, element buffer object. Now we are creating element buffer object. Scroll down, GL create buffers, 1 element buffer object. Don't forget, it should be address, GL bind buffer, binding target, GL element array buffer. This is binding target. We pass element buffer object. So we create buffers. It allocates name, unused name. Then we bind to its target. In this case, we are going to use this buffer as element array buffer. Now scroll up. Here we created a buffer and bind to array buffer because we are going to use vertex buffer object to hold vertex attributes or vertex position and the color. In this case, we are going to hold vertex index. This is vertex indices. If you haven't watched this video, you cannot understand. So, glBufferData, we allocate and initialize memory. glElementArrayBuffer. This is target. It means we are going to initialize element buffer object, the same target. Then size of this array, vertex indices, this array. So vertex indices, data vertex indices. We use it GL static draw. So we initialized element buffer object with vertex indices. Now we need vertex attribute pointer. We have to specify vertex attribute pointers. Don't forget this song. Create a vertex array, bind the vertex array, enable vertex attribute array, vertex attribute pointer. We can specify GL vertex attribute pointer. We set position. So this position index. Then size. This size means vertex position. Each vertex's element count. It has 4 elements. Each vertex has 4 elements. So we provide 4. Then type. Each vertex position's element is of type GL float. So GL float. I will make it bigger. Then normalized. We pass GL pulse. Stride. Stride is 0 because vertex position information is consecutive. Here, then this pointer is offset. Offset is simply 0. Or we can say void pointer. It is simply 0. Now we specify vertex attribute pointer for color like this. glVertexAttrib pointer this color index. Color index also has 4 elements for each color. GL float, GL pulse. Here stride 0. Now this offset. This pointer represents offset in the glArrayBuffer Vertex buffer object. We passed this value as offset for vertex color. So we have to provide this as a offset. It should be over void pointer. This is offset because we are specifying color. This offset means in the vertex array buffer we copied vertex color at offset this address. When we copy vertex color, we used this offset because we used glArrayBuffer for both vertex position, vertex color. In case of vertex position, we provided offset 0. In case of vertex color, we provided this byte offset. It's very important. Now, semicolon. We have to enable enable vertex attrib array. Now we enable position attribute. This position index enable vertex attrib array. We have to enable color. This color index. Now press Ctrl F5. Okay. Now close it. Close it. here GL front face. We use GL counterclockwise orientation. This is default OpenGL Vertex winding orientation. This is default, but I would specify explicitly. We are drawing 3D object, so GL enable GL curl face. We want to remove hidden face from our 3D graphics. I will remove blank space. Now, in the render function, I will convert current time to float. T is time. Typecast to float current time. Its unit is second, so we will multiply 10-second unit. Static constant Vmath. Back 3. This is y-axis. 00f, 10f, 00f. This is y-axis. Copy, paste. This is z-axis. 0.f, 1.f. Now, Vmath matrix 4x4 matrix. Scale matrix. Vmath scale. We can use 1.5 f, 1.5 f, 1.5 f. It creates scaling matrix. Vmath mat4 translation. Vmath translate 0.0f, 0.0f. We will translate negative 5.0f unit. Vmath mat4 rotation y-axis. Vmath rotate angle is t. We use t. Time is used for angle of rotation. Then we rotate with respect to y-axis. Copy, paste. Rotation z-axis. We rotate with respect to z-axis. Please note that this angle in degree. T is used for angle in degree of rotation. I would fix like this. Now, auto model matrix translation times scale times. We rotate rotation y, rotation z, parentheses, semicolon. The order of matrix multiplication doesn't matter, so we can use parentheses to change the order of matrix multiplication. Or projection matrix. We use vmath first term. The first is left limit. I would set 1, right limit 1, bottom -1, top 1, and 1.0 f. Then f, I would set 500.0 f. Of course, it can be float. Now, we have to set model matrix and projection matrix in this vertex shader. These are uniform. So, GL uniform matrix for FV 4x4 matrix of type float using vector. We have to provide uniforms indices like this. This model matrix index. Then count 1. Transpose GL pulse. I will make it bigger. Then pointer. This pointer is this model matrix. In the same manner, copy, paste. Now, projection matrix index. Also, projection matrix. We use GL enable GL primitive restart. We have to enable this option. Then GL primitive restart index. Primitive restart index is specified here, this value. Or we can say this value. Copy here, paste. Then glDrawElements. We are using GL triangle strip. We have 17 indices. Now scroll up. Here 8 for first strip. Strip 1, 8 indices. Strip 2, 8 indices. So total 16. Then restart primitive. So it is 17 vertex indices. So we have to provide 17 here. Then follows type. This indices type. This is GL unsigned int. So GL unsigned int. Then indices. We can simply pass null. This is offset. Offset indices. We will just pass null. Y is squiggle. I would just say GL unsigned. This is not GL unsigned. This is GL unsignaled. GL unsigned. signed int. Now press Ctrl F5. Okay, it seems to be working. If we resize, it is not centered. Now close it. Close it. To address this issue, Ctrl Home, right click, go to Definition. In the namespace SB7, you can find class application. In this class, you can find init function. I will copy, then I will paste. Here we can remove virtual, instead override. This is for Apple, so I will fix like this. I would use major version 4, minor version 5 or 6. I will select version 4.5. This is for debugging. Please understand that default window width is 800, window height 600. Now save all, right click application, then go to declaration, or here again we need on resize. For example, we need this one. Copy, then paste it here. I will override. Then SB7 application on resize. We pass WH. So these are set in this function on resize base class, virtual member of base class application. We don't need this. Now, if W is greater than H, we can say width, height. If width is greater than height, GL Viewport. See, XY starting point. So width is greater than height. We divide 2. Then Y is 0. Then width and height, the smaller of the two. Height. Else means height is greater than or equal to width. So copy this, paste it here. X is 0. Height is greater than or equal to width. Then the smaller is width. We change it on resize function like this. Now we have to call on resize function. In the function startup, at the end of this function, we declare int viewport size. It requires 4 elements. GL get integer v GL viewport. This is parameter name. We provide this array debug viewport size viewport size NL. We call this function to set viewport by passing this is width, this is height, width, height. Now with this, press Ctrl F5. It runs like this. If you resize, you can see the viewport resize. The viewport is always centered. I will change it here. In the render function, the scaling is too big. I will make it default. Also, I will copy this part and paste here. Press Ctrl F5. If you change or resize, you can see viewport size. Also, our cube is always centered vertically and horizontally. Always centered